Hello, everyone, and welcome to the Audio Product Development Alliance. I'm Roger Shively with Shively Acoustics, and this is the APDA, your gateway to audio product development. The APDA is founded by a team of us in the audio industry, committed to furthering the knowledge and the skills and of professionals involved in the development of audio products. That alliance is focusing on promoting methodologies, practices, and technologies involved in developing and bringing audio products to the market. I have with me today here, we have Dave Lindberg, who is part of that membership of the Alliance, who is the host of the THD podcast, as well as Steve Willenberg from LinkPlay. And our media partner is Audio Express, and Joel Martins is part of that group for us. Um, Joining us today will be Jeff Rogers, who is the VP of Sales and Marketing at Sensory. We are recording this on our YouTube channel, so you can check it out later if you want to, and please like us at all times. So, without any further ado, I'm going to introduce Jeff to have him get started. His topic today, but Jeff's background is 29 years in the industry of developing products for speech and computer vision, is what I know of. And you've brought a lot of things to the market, Jeff, in terms of speech and computer vision tech companies with them, such as Amazon, Google, and also in the auto industry, Mazda, Honda, Harman Automotive, Panasonic Automotive, and but also Lenovo, Huawei, Microsoft, Samsung, many more. Uh, so welcome to the Alliance. And today, I think you're going to explore some of the ways you can set up in-home systems or the home hubs. And also, you could make that a home hub in your car if anybody is interested in trying to figure that out, since you're doing some work in the automotive as well. So let me go ahead and give you the stage, and feel free to ask questions in the chat, everyone, and we'll pass those on to Jeff. And thank you.
Awesome. Well, thank you for the invite, and it's great to be here and talk about local speech technologies. Sensory's been around for 30 years, and I've been with the company from the beginning. So it has been an interesting ride. We actually started the company as a little semiconductor company back in the 90s. We were actually called Sensory Circuits back then, and we designed our own little 8-bit microcontroller that could do speech recognition, speech output, and it was a microcontroller. And our goal back in 1994 when we started was, let's create a single chip that can do all of these things. And that was a pretty high goal, because this is way back in the day. And we were successful at that. We won all sorts of awards for coming out with this chip. And back then it was a little 8-bit microcontroller, and we added some hardware assist modules, because this is before the DSP days even. And we ran that business for many years, and then when Bluetooth headsets came along, we said, wow, this is the perfect place for voice user interface, because they were these small little products. They didn't have a display. The buttons were small. It was hard to understand what does beep 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 mean, and flash 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 mean, and how do I pair this thing? And the return rates were really high on those things. And so we looked at it and we said, this would be a great voice user interface right here. But our little 8-bit micro was too big and too power hungry. So we looked at it and we thought, well, maybe we'll port our algorithms to another platform. And back then it was CSR, and it was the BC05 for the old timers in the group. And we did that, and we were very successful. And it was kind of that point where we realized, hey, we're a really good IP software company, maybe less of a chip company. And so over the years, we got out of silicon completely, and we haven't had our own silicon for many years now. But that backstory is important, because Sensory started very differently than a lot of other speech companies. We started with a focus on, I need to run this on something that has 2K of SRAM and 64K bytes of ROM, and all on an 8-bit microcontroller. And that was really hard back then. It's still hard today, which is interesting. But fortunately today, the chips and the platforms have gotten more powerful. But having that back history is important because we did start small rather than, well, I've got this great engine that runs in the cloud. Now, how do I get this to run locally? And that's always been a big challenge. And so that history has really helped us. So that was a really big turning point in our history. And then two other things that I would say really helped drive our focus and our success, and neither of which we had anything to do with, which is kind of interesting. The first is Apple Siri. When Siri came out, the speech tech was okay. It made a lot of mistakes, but Apple's an amazing marketing machine. And they convince people that, hey, it's okay if it makes some mistakes. This is cool. You have your own little assistant. And our business just exploded because all of a sudden people are like, hey, yeah, I want to be able to talk to this thing. And then the second was when Amazon released their Echo. Again, our tech was not used in that, but what it did is it brought an awareness to it's okay to have something always on and listening. And in fact, I want that. So prior to, I've been in sensory from the beginning, and I remember talking to the appliance industry years ago, saying, "Hey, we should have a voice recognition microwave, so you can just tell it what you want." And the appliance industry was kind of like, "Well, I think people would feel weird talking to their appliance." Those days are gone. Now it's very normal to talk to things, and it's really opened the door for this kind of explosion in voice. And we've seen some interesting trends, and I wanted to kind of talk about what's going on today and this concept of, is it possible to do an assistant that runs completely on device, so I don't have to worry about data and privacy and connectivity to the cloud and the internet and all of these things. And it's a challenging request, but it's one that I think is really interesting. So let's talk about what's going on today. So the changing cloud ecosystem landscape. Amazon pulls out. So Amazon last year announced, you know what? No more third parties can connect to Alexa. And I think they looked at it and said, well, we're losing, $20 billion a year or whatever it was, and let's let's stop that. And it left a lot of companies high and dry, which has been interesting for us because we're working with many of those companies that are like, hey, we used to be able to do this, and now we can't. Now what do we do? And Sensory came along and said, well, great, yeah, let's not worry about connecting to Alexa. Let's build something that runs local and can either continue to be local or run or go to other kind of cloud options. Google scaled back a lot on their support, and they also require custom and specific hardware, and can't really customize things. Who knows? These big companies can do whatever they want to do. They're in it for themselves, which makes sense to me. I'm not saying that they are going to pull out, but they might. I mean, they can do whatever they want to do. We companies, as it turns out, don't get to control these things. And then cost. Right now we're seeing an explosion in the LLM area, and a lot of these companies also have speech technologies as well. And some are offering free, but again, this can change at any time. And we're already seeing that with OpenAI now, who was this, hey, it's this free thing, and now they're they need to generate revenue. And so things can change, and they can start charging per minute, and which means that if you've got 1 million customers out there and each person uses the device an hour a day, wow, your costs can get huge and completely out of control and out of your control. And so the idea is, well, if we can run the whole thing locally, then we don't have to worry about per minute usage. We don't have to worry about the cloud guy changing, their idea, their plan, and it really puts the control back to the OEMs. So that's I guess kind of the idea and the topic that I really want to explore today is how do we do that, and what does that mean, and what are the options? So just like 2 days ago, I was getting my Christmas lights set up, and I have these smart plugs, and every year, and I don't know why they can't remember it, but every year I have to go through this setup. I mean, how many of us have bought these smart plugs, and you got to go through and they lose connection with something, and so you have to go through the whole setup process again. And in fact, on my mobile phone, I've got a folder that says Smart Home, and in it, I've got all these little applications, because each of the smart plugs and each of these smart devices, which turned out to be not so smart, have their own little app that you have to use in order to reset them up onto your Wi-Fi. And what I started doing is with my wife's little label maker, I was making little labels and sticking them on the devices saying this product goes to this app. Because a lot of times the products don't have a name or a logo on it. And you're like, how do I reset this stupid thing up? And as I think about it, a techie geek like myself, yeah, I'm going to go through this process because I'm a techie geek and I like to figure things out. But most people forget it. I mean, I asked my wife the other day, I said, would you do this? Heck no, she'd never even touch it.
No.
Yeah, it's just, so there's a lot of steps. So you got to buy the product, and then you have to find and install the application that goes with the product. And now there's usually a QR code. So you scan that. So then you have to install a new app on your phone, and then you have to plug the product in. Then you have to follow the steps, and then you have to make sure your router has the option for 2.4 instead of just 5.0, because a lot of these things can't jump on the 5.0. Then you got to wait for the connection. It takes a couple minutes, and as you're waiting for that countdown, usually it's 2 minutes, and you see the little thing spinning around, you see it counting down. I find myself just kind of going, I hope this works. I hope it works. Come on, connect, find it. And sometimes it doesn't. And like 2 days ago when I was setting this up, yep, I took my little smart plug, threw it away. Yeah, they're not that expensive, and just got another one out of the box and said, all right, screw that one, start all over. Then on your smartphone, you gotta go to the cloud and get the application, and sometimes you have to name the specific device, and then you test it, make sure you're all good, and then the last part is it's like shampoo, rinse and repeat. You got to repeat all the above steps when it loses a connection, and sometimes it happens with a power outage or a Wi-Fi outage, or just after a year, it seems like a lot of these things lose it. So I mean, these are all the reasons, and anyone that's done this, you totally get it. You understand. Yeah, this is a pain in the butt. Most people just aren't going to deal with it. So there's again, a lot of challenges there. So why on device? Well, I think I answered that in in everything I just said. Lowest cost of ownership. There's no cloud infrastructure required. And yes, you can still have OTA updates as long as you design that in. The OEM has complete control. No need to rely on a partner like an Amazon or a Google or others that can change their plans at any time. It's always on, always available. I don't have to make sure that, oh, gee, do I have internet connection? Sometimes that goes out. Complete data privacy and control. So if we do, and I'm going to show a couple different demos today. A couple where everything is 100% on device, and then another where let's take advantage of LLMs. I think LLMs are amazing. We love them. We use them all the time at Sensory, and I think there's a real interesting fit there. And today they're mostly in the cloud, but tomorrow they'll be on devices. And Sensory is even designing our own micro. I guess if you could just say micro LLM, so a micro large language model. But anyway, so these are always on, always available, complete data privacy. This weirdness of like, for anyone that has an Amazon product, you can go into your Amazon account and you can see everything where each time where the device false fires. And you'd be surprised at how many times that those devices do false fire. A false fire means that I'm talking and it thinks I said the wake word and it goes and does something. And you can actually listen to the audio that's captured in your home, which is kind of creepy. And so sometimes you hear your kids yelling in the background or other sounds that you probably wouldn't want to be captured. And Amazon will label those as not intended for Amazon, but they still get it. So that's the point. And if you do everything on device, all those issues and concerns go away. And then, as I mentioned, our roots, our history is we want to run really small. So we have it's really flexible. Lots of we can run on a CPU, can run deeply embedded. We can do these hybrid approaches. If you want to connect to an LM as an example. So again, a lot of options here.
And Jeff, is there any processors? Are there any specific ones that are needed, or are you agnostic to really virtually anything that's out there right now?
So pretty agnostic. We support. So it depends. I mean, if you're running on an application processor, yeah. I mean, a standard application processor running, Linux, Android, Windows, Mac. That's pretty normal. We can support any of those today without really any customization. If you want to go more deeply embedded, where you want to have low power as an example, Yeah, we can run down at a DSP level, and we support more than 20 different platforms there. So there's a lot of flexibility in what we can do. Yeah, thanks.
So
That's a great
you
question.
said 20 different platforms. Are they geographical or commercial? What are the differences in those platforms, and how many are available to you besides the
So
20? I mean, are they
yeah,
local environments or?
yeah. So when I say more than 20 different platforms, more than 20 different chip platforms. So
Okay.
chips that are based on an M4 processor, yeah, we can run on those, or an M7, or the new ARM U55, M55, or M85. Any of those platforms are supported. Any chip that's running like a Cadence Hi-Fi 4, 3, 5, any of those Hi-Fis, we can support those as well today.
Okay.
So yeah, and so across the board, we support a lot of different chip OEMs that make chips, and they've come to Sensory and said, "Hey, we need your technology running our platform because we've got customers that need and want these things."
Well,
So
that
it's
makes
very,
sense.
very flexible, is what you're saying.
Yeah,
Yeah,
super
because
flexible. Yeah, you're not shoehorned into, well, as long as you can run this only on this specific platform, you're okay. No, there's a lot of options here.
and it keeps you from being locked into something that's embedded just for one thing, like like you say, the refrigerator or whatever you wanted to talk to. You don't have to worry about that being your only application. It can go across a lot of different devices, and it sounds like that's
Yeah,
good.
exactly,
Yeah.
exactly.
Okay. Yeah.
Yep.
Thanks. Good.
So this concept of the home hub, and in my little picture there, and I used an LM to actually draw that picture, which is super fun and cool. I put your name here, home hub, and the concept is, rather than having OEMs have their customers saying, Alexa to things or Google to things or Siri to things. No, have them be custom. It should be your custom wake word. So that, that's what I'm starting off with. Let's start with a custom wake word. Build your brand, not theirs, not others. I think that's super important. And we can do that totally today. So Truly Hands-Free is our technology that's been designed into more than 3 billion products worldwide from a lot of the companies that Roger mentioned as he was introducing me. So the concept is, with this home hub concept, we can put the power of speech to text and full-on natural language in this home hub product, and then have a bunch of
No, Chuck,
satellite.
yeah.
Sorry?
Sorry. Okay. No problem. Thank you.
Yep. And then we can have a lot of satellite projects like lights and plugs and fans and AC units and blinds and appliances and etc. that run just our little Truly hands-free with a simple microphone. And so these can run a really inexpensive, tiny little chip that's just running the wake word. So that's always on, always listening in these little satellite products. And then we run our new TrulyNatural speech to text, and I'll show you demos of all this in just a minute, in the home hub base. And so this allows for natural language control of all the satellite projects. So right now, what we're doing in the market is we put a lot of commands, or as many commands as we can, in these satellite products. So as an example, there's excuse me, a huge company in India called Havels. And Havels is like the GE of India. I mean, they literally make 100 million products a year, and they do a lot of fans and AC units and water heaters and this sort of thing. And right now they have us in all those products. But the concept that I'm presenting here is we can just keep it really, really simple and low cost in the satellite products, and then have a connection to this home hub thing where we run our truly natural speech to text. And that allows for people to talk like they do to their Google and Amazon today. Then the concept would be that we use Bluetooth or Wi-Fi or Matter or Zigbee or, as I said, whatever, and it communicates from the satellite product to this home hub. And again, where the home hub it's more expensive hardware because it's running more powerful processor and more memory, but then all these other products can connect to it. And this allows us to not have any reliance on cloud partners that can change their game at any time. There's other options we can talk about for customization. So we could have a custom wake word. So Sensory supports a fixed wake word, which is most people understand. Like when you say Alexa to Amazon, that's a fixed wake word as an example. But we can also do enrolled fixed wake words. So when I say the wake word, it says, okay, I heard the wake word and that was Jeff speaking the wake word. So now I know that it's Jeff. And so I could have, if this were a panel in a home for home control, when I say the wake word, the panel could automatically adjust to my home screen. Same thing with a TV. When I say, as an example, in most LG TVs, high LG, that Sensory's wake word that you're using in there, but it's a fixed wake word, so it just triggers, okay, I heard the wake word now, and anybody can say it. If we did an enroll fixed wake word, when I say the wake word on my LG TV, I'd love to have my own screen. I don't need to see my wife's screen and her channels or my kids. I just want to see mine. And so having an enroll fixed wake word ensures that the user is, number one, saying a phonetically strong wake word, and two, it builds the brand, because you have to say, hey appliance, or whatever the OEM's wake word might be.
So,
Yeah.
so that means that it's a phonetically different. You can have two different wake words running on a device or multiple ones, but they're phonetically different enough. Is that what you're saying? So you can have two different ones at once, or how does that work?
So that's a great question. We can run multiple wake words at the same time, and in a minute I'll show you a demo
Okay, all right.
of that. But here what I'm saying is we can still run multiple wake words, but we can also have the user enroll if we wanted to, so that when the wake word is
Okay,
said,
all
the
right.
device knows it was me saying the wake word. So as an example, NEC PC in Japan, they're using our Truly Hands-Free for the wake word, and they're using our Truly Secure Speaker Verification voice biometric. And so when I say the wake word to my NEC PC, it says, I heard the wake word, and that was Jeff, and it unlocks the PC.
And Jeff, can you run multiple language at the same time, i.e. Japanese and then English?
Yeah, we can. There's a couple different ways you can do it. In fact, I don't have that demo with me today, excuse me, but I once created a demo where I was running two different wake words. One was in Japanese and one was in Mandarin, I think. And then after the wake word, I was running a US English set and also a Korean set. And so you can do that. You can also just allow the user to pick their main language, and that's an easier way to go. But we can support both of those things. Yeah, great question. And then lastly, we could also support a user-defined wake word. So this is language independent. It works out with any language in the world. It allows the user to choose their own wake word, and then we can also apply speaker verification and speaker ID to it as well. So there's a lot of options here for some interesting customization. Other things we can do, we also have a sound ID technology. So we can run sound ID in the home hub or the satellite products with a stage 1, stage 2 kind of thing, where we can listen for glass break and alarms and doorbells and baby crying and dog barking and more types of things. We can even listen for customer specific sounds. We've got an enrollment capability, just like with a user-defined wake word as an example, where if the user has a specific sound they want to listen for, they just play that sound 4 times. It learns that sound. Like, I can do like crumpling paper, or maybe I've got a bird that has a specific bird chirp cry kind of thing. I could enroll that if I wanted to. So there's some more kinds of fun things that we could do here.
And what kind of sample size do you need on the edge to create those custom words? Like how many times would typically people need to repeat something? Or you said 4, but that sounds kind of small. Is that good enough?
That's good enough. I mean, anyone that has
Really?
an iPhone knows that when you get it, you have to say Siri 6 times to it. Yeah, our enrollment time's 4 times, and that's both with wake words as well as the sound ID. I guess the hard requirements that we have is that we enroll in a quiet environment, because when you're enrolling, you basically, everything the microphone hears is becoming part of that template. So if I enroll and I've got this, running in the background, that's going to be part of the enrollment, and so that can
Yeah.
kind of foul things up. So our requirement is enroll in a quiet environment and then use in any normal environment. So like at CES, I will enroll custom wake word in my hotel room, and then on the show floor with 10,000 people around me talking, yeah, I can use it and it works great. But I did enroll in that quiet environment.
Okay.
Yeah.
Does that actually enhance the ability to do what you're showing on the screen here, is to pick up sounds that are outside of or is that a completely different process that sound IDs when you're looking for noises that aren't part of the wake word? Is it?
Yeah, good question, Roger. They're completely different technologies. The sound ID is modeled very differently. So if we wanted to build a sound that is a kind of a standard sound, and in our sound ID, we've already defined 16 different sounds, and they include a lot of these that are here and more. But some of our customers say, hey, this is a custom sound that we need to recognize. For that, if we want it to be a standard sound, at a minimum, we'll want 1,000 examples of that sound. 2,000 is better. More data is always better. But if it's a custom sound that I'm doing just on my own, I think to kind of answer David's question, yeah, then it's just enrollment of 4 times. But if I want to make it a standard sound that ships in all the products and you don't have this custom enrollment kind of thing, then yeah, for our sound ID, we would want a minimum of 1,000 sounds of that. And a lot of times you can get those sounds, you can scrape them off of YouTube and others. So let's kind of talk about Home Hub with LLMs as well. So the idea here is we run the wake word local, and it's custom wake word, hey, wake word. And then we run the acoustic model local. We run the speech to text local. So all that stays local. Set the temperature in the bedroom for 67 degrees and close the living room blinds, as an example. Then all we're sending to the LM is just the text information, not the voice data, not the recording of me. And so it's significantly smaller amount of data, and you don't have the issues of your voice going somewhere else outside the home. We use the power of the LM to interpret, basically what's the intent entity. Okay, it's to set the bedroom temperature for 67 and close the blinds in the living room. Then you can have feedback with text to speech as an example, or just on the display. But using the, LLMs are amazing. And I'll show you a demo that I literally created in about 2 minutes. It's unbelievable how well it works. They're really, really good at pulling kind of the intent entity. And one of the concerns with LLMs is they hallucinate and they go off the rails. And yes, they can absolutely do those things. But if you put guardrails around them and limit them to something more specific, like a home automation assistant, then they can do a really good job. So let me pop out of here, and let me show you a couple of demos here.
Okay. And while you're doing that, I'm assuming that most of the audience is familiar with large the language models that you're talking about, but that may be a topic for another webinar to talk about what that all means. But to what degree you said that Sensory created their own language model. So is that the essence of where you began developing the home hub ability, or is it something that came along after you were already started?
Yeah, good question. It actually started with automotive. So as you mentioned in the intro, we're doing a lot in automotive today, and we're seeing that grow very rapidly for us. And there's a couple reasons for that. One is the speech tech traditionally in automotive, it just is not very good. You a lot of complaints with it. It's one of the #1 complaints that people have, and a lot of times people just don't use it because it hasn't been that good. Then Amazon and Google came along and Siri came along and said, hey, you know what? We can do this, and we'll do it mostly in the cloud, some on device. And so CarPlay and Android Play are very popular, and they work really well. I think it's a really interesting model. But it's more challenging to control all the devices in the car because, again, they're focused on their cloud. They're focused on sales and connecting people to these these services so you can sell more things, and less about, well, let me customize this specifically for the car. So we looked at that and we said, well, let's see. We can do a custom wake word. We're really good at that. Lots of experience there. And today, Honda cars, if you say Siri, that's Sensory in there. And the enhanced Siri is something that's specific to automotive. The wake word is just Siri. It's not Hey Siri. So it's a 2-syllable wake word. And phonetically, it's horrible. There's no good hard sounds in there. And, if you say seriously, it's going to trigger on that. And if you say, hey, Sarah, or Sarah, it's going to probably trigger on that. And so Apple came out with this enhanced Siri requirement that's really, really hard to make, to meet that requirement. And Sensory does. And as a result, in Honda cars today and Mazda cars today, and there's another huge European OEM that's going to be shipping vehicles next year that's going to be using our tech there, along with some others that are coming along. So we started with, okay, we're really good at wake words. Then we developed this TrulyNatural speech to text. And TrulyNatural speech to text is just that. I want to be able to just speak normally and have it recognized. So here I'm running an automotive demo, And let me see if I can, yeah, okay, so I can pick my language that I want. So I've got, oh, I don't know if I can change this in this screen. We support more than 35 different languages today. I'm using the automotive domain. I'm using a large model here, and I'm using a standard Voice Genie. And this large model, by the way, is only like 200 megabytes. When I say, oh, sorry, I said the wake word there. Let's stop this here. When I say large, I mean, like 200 megabytes. So let me see if yeah, for some reason I can't quite change this. Let me relaunch the demo here and see if I can show how I can change these. Here we go.
There
Okay.
you go. All right.
Yeah, so yeah, that one was the large one was 224. You can see we've got a really small one here. It's only 34 megabytes. It's tiny. So in that 34 megabytes, that includes the acoustic model, the automotive language model, the micro language model that we're using for NLU, as well as an action lookup. So there's a whole bunch going on in that really small model. So that's the one I'm going to use. I'm going to use the really small one here. So now it's on and listening, and so I can say anything that I would say to control a car, such as Voice Genie, roll down the front windows.
Opening the front windows.
And so I don't know if you could hear that in the background as well.
Yeah.
So you can see here it's showing what I said, and then it's pulling out the result. The intent was to open a window. Which one was it? It was the front window. Or things like Voice Genie, turn on the cruise control and set the speed to 73 miles per hour.
Setting cruise control to 73 miles per hour.
So it's super fast because this is all running local. So here, there's no cloud touch for anything. And even things like, Voice Genie, what's the flashing icon on my dashboard mean?
Showing the driver's manual for the active warning lights.
I mean, stuff like that would be amazing, where you could just say that to your car. And today, most cars don't support such a thing. Or, when I take my wife's car through the car wash, I need to turn off the parking sensors. Otherwise, they go crazy the whole time. To do that, it's literally like a 10-step process. On the steering wheel, there's a little gear button. I have to go over to that, and then I have to push it, and then I have to scroll down to parking sensors, and then I have to hit that, and then I have to toggle on and off. So there's all these little steps I have to take. It'd be so much easier if I could just say, Voice Genie, turn off the parking sensors.
Disabling parking assistant.
It's awesome. Okay, so we're already, this is a great solution for cars. And so, yes, we can do a completely in-car assistant, even including like full-on speech to text. So I can say something like, Voice Genie, send a message to Todd. Let Todd know that I'm doing a webinar right now. And it's going really well, and it's fun to be able to show how well our speech to text works.
Sending message to Todd.
So it was actually going to try and send that message there. And you could see I was just kind of rambling and talking. You'll also notice that different colors in words. Black means very high confidence. This darker red here means a slightly lower confidence, and the brighter the red, the lower the confidence. Now, it still got everything correctly, but we're exposing that so the developers can actually use that and make decisions based on, okay, how accurate is this?
So, good question for you. What you just did is what most of us know about, it's speech to text. And so this is quite unique in terms of finding the intent of what you're trying to say as well, which I think is, different from a lot of the ones I've seen before.
Yeah, no, it's a good point. And so here you can see the intent was to send a message. The contact was Todd. So here the message is just what the message is, and not, it doesn't take all this. It's like, what was the message? Okay, I'm doing a webinar right now, blah, 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 blah. Exactly.
I like
so,
it.
Yeah.
There was some people grumbling about creating that speech to intent. Some guys in Montreal a couple of years back, and they were skipping the step of the transcription. And so are you guys doing a combination of intent and transcription, or how does it refining that?
So what we did here is we actually created our own micro language model to basically say, what are all the different things you might say to a car? And then based on the speech that we're getting from our speech to text, we take that and we apply it to that little micro language model that we developed and said, okay, you said this, and what you really mean is this. And that's really the speech to intent thing that we're doing. That's the tricky part. And in this case, what you just saw here, everything's running in 34 megabytes, which is tiny, tiny, tiny. So this will run in any car today. It doesn't have to be some high-end expensive car. This can be the low-end basic cars that we can run this because it's a really small model. So yeah, it really is putting those two things together. And that's where it can get kind of tricky. So you know, what I did is I took this concept, well, we're doing this in automotive, we should do this in the home. And so let me see if this will work here. I'll change, no, I have to do it here first, sorry. So here, I'm going to change from automotive to just a general model here. So there is no NLU anymore. This is just a general model, but the concept here is to show how accurate the speech to text can be. So here I can say, Voice Genie, I want to turn on the lights in the bedroom and lower the blinds in the kitchen and open the garage door.
I want to turn on the lights in the bedroom and lower the blinds in the kitchen and open the garage door.
So this concept of this, the home hub can be, yeah, I can do all these things. I can speak very naturally. And then there's two options. One is we could create a micro language model like we did for automotive, specifically for a home hub kind of application, or we can go to an LLM and do that. So let me pop to another demo here where I'm taking advantage of an LLM. Okay, so here, this is an example where the wake word is going to run local, the speech to text is going to run local, and then I'm just going to send that text to an LLM in the cloud. And those, again, those can be small, large, whatever, and it's a variety. We're not specific to any custom LLM. But I basically defined, I did a little prompt engineering saying, you're a home assistant, you'll identify the intents and entities, and you'll respond in 20 words or less. I don't want some chatty thing. I just want, okay, what are we doing? What did I say? So here, everything's the wake word again is gonna run local, the speech to text is gonna run local, and then I'm going to the cloud for the LLM, and I'm just sending the text to the cloud. So everything can be very fast. So as an example, I'll do that similar demo that I just did with our speech to text. Voice Genie, turn on the lights in the kitchen and set the temperature in the bedroom to 65 degrees and lower the garage door.
Intent, control devices. Entities, lights in kitchen, temperature in bedroom, garage door. Lights in kitchen turned on. Bedroom set to 65 degrees Fahrenheit, garage door lowered.
So I literally created that demo in like 2 minutes with a little prompt engineering and then throwing everything in the cloud. Now you did see that there was more of a delay.
Yeah.
So the advantage of doing everything on devices, it's instant. The advantage of this approach is I don't have to develop that complex NLU, the micro language model that we're doing. But both are possible, and that's one of the nice things about an LLM is you can say things like, Voice Genie, set the temperature to 68 degrees. No, wait, that's going to be a little warm. Let's go with 65. You know what? Actually, let's go with 67 degrees.
Intent, control devices. Entities, temperature in bedroom. Bedroom temperature set to 67 degrees Fahrenheit.
So the amazing part of that is all this rambling I did up there. Oh, let's go with 6. Oh, you know what? Da, 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 da. And it, the LLM gets it. Oh, what you really meant was 67. Got it. I'll make that change.
No, this is valuable.
Yeah, that's fantastic.
Humans are involved. It's invaluable. So, I have a quick question. You mentioned wake words and what's the best one. I mean, how many times have we said something that's close to Alexa or something that's close to Siri, and so you worked on getting those more robust, or are you also suggesting there are hard consonants and things like that are better wake words than ones that are soft? I think that's one of the things I was curious about. Because when you mentioned the automotive thing, you had to make it better for the Siri interface, but I'm assuming from that you learned what was best for simple applications as well.
Yeah, it's a great question. In fact, we just did a webinar last week, a sensory webinar. So you can check our site, and we did a webinar on wake words, and we spent 45, well, I guess a half an hour talking about wake words and how to define a really good wake word and what makes for a good wake word. And we invited a couple members from our linguists and speech technology team to join that webinar. So if you go to Sensory's website, you'll see a link to that. And we really kind of dove in deep. How do you define a good wake word? But as a at a high level, we typically want a minimum of 3 syllables. 4 is sometimes better. And we want a good hard sound in the middle. I mean, there's a reason why Amazon used Alexa. It's the X sound, which helps put a hard stop between the two sounds on either side. And hey Cortana with the C, and OK Google, the K and the G are good hard sounds in there. In fact, my phone just went off because I said that. But because this is our business, we work with our customers, and they'll typically say, this is the wake word we want. And then we'll score that phonetically, not marketing wise, but phonetically. What makes a really good wake word? And we'll go through that with you. But yeah, check out our site and check out the webinar we just did last week on that.
Okay, good. I have a question. So I'm developing a product, and this is quite fascinating. The fact that in the car I don't have to go to the cloud, which is always a subscription, right? So you don't have to worry about that in the car as well as your house. But if someone is developing a product for either of those environments or anywhere, how do they start working with, create this a voice hub? How do you get started with doing that? Is it something that Sensory is solely providing on these platforms?
That's a great question. So let me answer that by showing you a tool that we've created called VoiceHub.
Okay.
VoiceHub is a tool we created to allow customers, developers, companies to develop their own custom wake word and custom phrase spotted command set. So let me see here. Okay, so what you're seeing is our VoiceHub tool. And this again runs on a VoiceHub server, and so people can get free access to this. And here you can create a custom wake word, you can create custom simple commands, you can create a TrulyNatural natural language grammar. So this is not the speech to text, but more of a grammar. And so I can go in here and I can say, well, I want to create a custom wake word, and so I click that. Then I can name the wake, name the project that I want. I select the language that I want. You can see that there's a lot of languages that are supported in VoiceHub for creating these custom wake words. And I would stick with US English for this demo here. Then I can select the size that I want. What platform am I running on? Is it on an application processor? Great. I'm going to use a 1 megabyte file. The larger, the better. But in some cases, we're running on really tiny little DSPs and microcontrollers. And so, okay, I need an 80 KB size. So again, you can see there's options here. Then I type in the wake word that I want. So I could just type in, hey, Sensory, as an example. And then over here, you see this little speaker icon. That's actually going to play a TTS engine that's going to play a pronunciation of what the recognizer is expecting. So if I type in, HBO with no spaces or periods, it's going to come back and say, hubbo. And I'll say, oh, no, that's not what I meant. So then I type in H period, B period, O period, and then it would pronounce it as HBO. Okay, great, I got it. So you can do a little bit of kind of your own tuning right here. And then the last part is this operating point. There's always a balance when you're doing wake words. There's a balance between false accepts and false rejects. And a false accept is I'm just talking, it thinks I said the wake word. And a false reject is I say the wake word and nothing happens. The tool is going to come up with its own recommended operating point, but you can change it. I mean, you can say if I want very few false accepts, I'm going to go with an operating point of 1. It's going to be very low false accept, but my false reject will be higher. Or conversely, I might say, I definitely don't want a false reject, and so I can use a really high point like 21. My false reject will be very low, but the false accept will be higher. So again, there's always a balance. And so here with VoiceHub, there's no data, there's no recording, there's no enrollment. It's a proprietary synthetic data approach that we developed on our own because we've been in business for so many years. We've got a ton of data that we use for this. And so once I hit build down here at the bottom, this custom wake word, it usually takes 45 to 60 minutes to build because it's using all that data and it's building this model and it's balancing between FA and FR, and then it comes out. But I can still go in and I can change that operating point if I want. So rather than take the time for that, here's an example. I've got a dishwasher. Because I'm getting older, I can't see the tiny little 0.6 font that's down there under the buttons. And so I said, let me make a demo of this. So dishwasher commands, and this is, I used VoiceHub to create a wake word here. And then, as you recall, there's 3 different projects you can create. One is commands. So here, I just typed in all the commands that are on my dishwasher, pro wash, top, etc., etc. And I built that all into one set. So then I can download this once it's built, and here you can see the whole thing is 512 kbyte. That includes a 200 kbyte wake word, and I think I chose 80 kbytes for the command set. And then it grows as I add words to it. So then I can scan this, and I've got an application on my phone called VoiceHub, of course. So then I hit scan. I want to scan the QR code and load this file in. And now I've got that same file that I created here now running on my phone. And so now I can do kind of instant testing. So, you know, an engineer would test it by saying, Voice Genie, Pro Wash. Hey, it worked great. Look, there's the result. But that's not reality. People are going to say, Voice Genie, Pro Wash. And so I didn't have any space between it. Or they're going to say, Voice Genie, 4-hour delay, please. So even though I said, 4-hour delay, please, it still spots that out of there. It makes it really, really well, easy to use. Voice Genie start. I just want to say that and have it start the dishwasher. Or when it's running and I need to pause it because I'm on a phone call, Voice Genie cancel. And it's going to cancel the project. So talking very naturally, and again, this is all running on device. And this whole file was 500 kbytes. So this is tiny, really, really small. So we can use, and I understand we're probably getting short on time here. We can use VoiceHub to create custom wake words, custom command sets. Earlier, Steve or Roger asked about running multiple wake words at the same time. So here's an example. I call this my retail shopper emotion detector. And the idea was we could build a product that sits at the end of an aisle by a display. And as people walk by, they could say, I hate that. I love that. I don't like that. I need that. And so, you know, I don't want to, privacy reasons, I can't record them in the store, obviously. And all I want to do is just kind of keep track of, do people generally like what they're seeing or not like what they're seeing? So in this case, this is a 1, 2, 3, 4, 5, 6, 7, 8 word wake word set that's running all the time. And so I can you know, do the same thing here where I download this into my little app here, scan the QR code, and then run VoiceHub here. And so now it's on and listening, and these are all wake words running all at the same time. So if somebody comes by and says, I love that, then it's going to log that and say, oh, somebody really liked what they see. Or somebody might say, oh, that's too expensive. And it's going to say, okay, I'm going to log that as well. So these are multiple wake words running at the same time. And what we're seeing in automotive now is we're seeing cars that, you know, the OEMs that want to run multiple wake words at the same time. So maybe I want to go to Siri, and maybe I want to go to Alexa, maybe I want to go to the cloud, or maybe I just want to do local car commands, and let's use a local car wake word for that. And so again, we can run multiple wake words at the same time. So there's a lot of tools we've created. All these tools really made it much easier for companies today to say, okay, how do we make an assistant that runs in the home or in the car or elsewhere? And combining, you know, really good wake words with awesome speech to text that's very small, that can run across a lot of different platforms. That's really the magic sauce that enables all these things.
That's great, actually. And you mentioned also back previously the different platforms and the different partnerships you have there. So it's not something that has to be embedded per se in a you know, you're saying it could be any access that you need. So it doesn't have to be an embedded product that stands alone by itself. It can be something that can be pretty universally accessed. I think that's important. We are running short on time. I'll see if there's any questions from Steve or Dave, and we can catch up. We've caught up on most of the chat, so I think we're okay there. And there's your partnerships. There you go.
Yeah, these are all companies that have actually done real stuff with sensory. So you see a lot of big names there. You know, we're not new to this, and you know, even huge companies like Amazon and Google and Samsung and others that have their own speech engines, they still license sensory technologies for, you know, particularly for the on device embedded side of things.
That's great. Well, I'll start to wrap it up here for you, but that was great. Thank you, Jeff. I appreciate that. Anything, any comments or questions, Dave?
Yeah, no, I just think that the technology is fantastic, and you know, with Sensory and LinkPlay, we've had a long collaboration, and we're looking forward to the next generation. This is great stuff, and really, really appreciate the time that you spent today.
That's great, actually. Yeah.
Yeah, just to one thing was like I heard recently that yes, we've been aware that the third party assistants have been put on hold, especially or canceled, the Alexa one, but the Google one, apparently they're working on some refinement to their back end or something, and they will be relaunching their third party services in the coming year or so. Have you heard the same, or is this? So I was told by Stream Unlimited this detail.
Yeah, I've heard rumors of that. And again, with these large companies, they can do anything they want to do. So whether they actually do it, they might. Right now they do require, you got to use, custom hardware with it and some other things. They've got some other requirements. Will that still be the case with the new ones? I'm not sure. And for sure, they want you saying, "Hey, Google," to things. They don't want you saying, "Hey, custom wake word."
Yeah,
They want to support their brand, not your brand.
Yeah, and for people watching, just like the data collection, of course, is one of the goals behind that. A couple points on
Right.
that, of course, Amazon for selling, but then also a few years back, I think Steve, you were there when Ken Lowe from Vizio was telling us how he managed to drop the price on his televisions, and it was because he was collecting data and reselling
Yeah.
that. So that's another thing. But just to end on a lighter note, one of the big reasons to go custom wake word is, of course, privacy. And I don't know
Yes.
if Jeff even remembered the big prank that the South Park cartoon played on Alexa when they got the Cartman character to add something naughty to everybody's Alexa shopping list. But
That's
I'll
nice.
leave it on. I'll leave it at that note on privacy.
Well, thanks, Dave.
Well, on behalf of the Audio Products Development Alliance, Jeff, we again really appreciate your time, and look forward to having future discussions.
Yeah, and Sensory has some upcoming events, or I know you'll be at CES. You've had a workshop last week. Is there anything else coming up for you?
Yeah, thanks for asking. So yeah, look, check out our site for the webinar on wake words. It's really interesting. It was well attended. We had 157 people attending that one. And yes, we'll be at CES, of course. We'll also be at Mobile World Congress. We'll also be in Embedded World. So we typically hit the big shows.
Okay, good. Thank you very much. As far as the APDA, we'll have another webinar coming up next week as well. Plus, we'll be at at the CES. And so next week, on next Tuesday, we'll have Head Acoustics talking about zone measurement of personal zones in automobiles again. And words are important there as well. It's part about how well we can sense the sound that we're listening to in a car. And after CES, we'll have another one online here with Comsol about acoustic simulations in cars and for products. And then I don't know anybody else, but we'll be headed to the ISE in Barcelona in February. So that's what's coming up soon. We'll have more announced later. I appreciate everyone's time. Thank you. And we are recording this. It'll be on the channel, so you can revisit it any time. And if there's any questions, you can always reach out to the contributors here today. Thanks again. Please subscribe to our channel and keep an eye open. We're going to present more and more for you every day. So thanks again to Jeff Rogers from Sensory, Dave Lindbergh, THD Podcasts, and other great things in Hong Kong, and to Steve Willenberg from LinkPlay, and myself, Shively Acoustics here in Seattle. Thanks, everyone, and have a great day. Appreciate it. Bye now.
Take care.
All right.